Total Pavement Acceptance Device, or TPAD, we wanted to try to combine two very useful technologies that TxDOT has. One is collecting rolling deflections, basically continuous deflection file, and the other is coupling that with ground penetrating radar. So previously we had these technologies separate. We wanted to combine them and improve upon them in any way that we could. Why do we want to do this? Well, pavement structures, to be properly evaluated, should be evaluated in a continuous manner rather than at discrete locations. And that's really the problem with testing right now, is most of it's done at discrete locations. So do you have full information about your pavement if you're only looking at discrete locations? Probably not. So if you can combine a continuous process, you can give the engineer much more information to make relevant decisions about rehabilitation strategies. This was really a tremendous technological undertaking. Even though we had the technologies that existed in the past, what we never had was really a way to evaluate the entire system while data was being collected to ensure that the data is quality data. We never really had a way to ensure that the load in part of the pavement was constant, uniform, met certain specifications in the past. We now have software and hardware that monitors all these operations while the data is being collected. This particular device was actually sole sourced from Industrial Vehicles International out of Tulsa. The basic platform is a oil and gas technology device for use off-road, used in seismic testing to basically shake the ground and derive information for oil and gas technologies. What IVI decided to do on their own was to develop a prototype of a pavement shaking system that somehow mimicked the earlier RDD, the rolling dynamic deflectometer device developed by CTR. IVI adapted rollers similar to the loading rollers on the old RDD, and these rollers can impart both a static load and a dynamic load while the vehicle moves forward. With the old RDD, we were able to test at speeds of 1 mile an hour, very, very slow. With this project, we were hoping to get up to approximately 10 miles per hour, which would be just a quantum increase in speed. By the end of this project, we're very comfortable with a forward rolling speed of 3 miles per hour. And I think we basically came to the conclusion that with the current technology that's used in this device, you probably will not be able to do much better than that because of the excessive noise that just becomes impossible to filter out. If we want to go faster in the future, it's going to take an entirely different technological track than what we're using here. We believe now that we have a very viable and robust testing platform that's going to give us a kind of a synergistic effect with both the radar and the rolling dynamic deflections together, allow an engineer to very thoroughly evaluate the structural properties of a pavement. In the past, the rolling dynamic deflectometer was pretty much limited to evaluating jointed concrete pavements. Now we hope to expand out to all forms of pavements, and so far we actually have tested a continuously reinforced concrete pavement up in Wichita Falls, as well as a very deep hot mix pavement down in the Houston district. Ultimately, we should see some benefit in terms of saved taxpayer dollars by making lots better decisions with our rehab strategies. And if we get to the point where we can use this as a quality assurance tool, then we can also expect better evaluation of pavements before they're turned over to TxDOT, before they're turned over to the state, to ensure that they do comply with our specifications.